Okay, today we will be looking at section 1.7, which is modeling with equations. And it is word problems, and I know that evokes a lot of emotions and maybe a lot of fears for you, but we're really going to take this and look at different specific models of different ways to approach the problems. Hopefully you'll find it organized and helpful as far as how to approach these problems. I'm going to look at a lot of examples during this lecture, and if you start feeling like you really understand it, then you don't have to look at every one of the examples, but I would encourage you to try most of them. Okay, a few guidelines here. First of all, we want to identify whatever variable we're going to be working with. So when we read the problem and we figure out what we're looking for, then that's going to be our variable, and we need to denote it with a variable like x. We want to translate from words into algebra, and sometimes that's going to involve drawing a diagram or a table to help us keep it more organized. We're going to set up specific models. Some of our models may be mixture problems, some may be how long it takes to do some type of job, some may be a geometric. So we're going to have different models that we'll look at, and then finally we're going to use what we know about solving equations to solve these equations, and then check our answers to make sure that they're reasonable. Okay, the first example that I want to look at is one that involves fixed and variable cost. And the example that we're going to use is renting a car. So we know that when you rent a car, you pay a flat fee for the day, and then you also pay so much for each mile that you drive. And that model can be used for other things as well. It used to be data plans and cell phone plans were set up this way, where you paid a monthly fee, and then if you went above that, then you had to pay so much per each minute that you used. A lot of them have gone to unlimited plans now, and that's not so much the case. But there's a lot of cases where you have a fixed cost and then a variable cost associated with it. So in this particular example, we have a car rental company charges $30 a day and 15 cents a mile for renting a car. Helen rents a car for 2 days and her bill comes to $108. How many miles did she drive? So if we're looking at this model here that we see, we've got our total cost, and that's made up of the mileage cost and the daily cost. Okay, so our total cost, when we look at it, we find that her total bill here is actually $108. So in the place of the total cost, I'm going to put the $108 there. Okay, her mileage cost, that's going to be how much it costs per mile. So that's going to be this 15 cents. So we're going to have 15 cents. And the question is, how many miles did she drive? So because our mileage cost is based upon how many miles she drives, we're going to let X represent how many miles she drives. So the mileage cost is going to be 15 cents times that. And then to that, we're going to add her daily cost. And she rented this car for 2 days at a rate of $30 a day. So that's going to be $30 a day times 2 days for the rental. So this is the equation that we need to solve. And from here, it's just a linear equation. I'm just going to recopy it down here so we can work with it a little bit better. Okay, if we subtract the 60, we're going to get 48. And then we want to divide this away, divide the 0.15 away. So X is going to be 48 divided by, excuse me, 0.15, and that's going to give me 320, and that's going to be miles. So she drove 320 miles. We know that because we know what her total cost was. We know how much she paid for the daily rental. And then we also know what her mileage is. And so you could check that and make sure that would be correct. Okay, moving on to talking about some interest problems. Interest problems, there's some vocabulary that if you're not familiar with interest, you need to kind of refresh yourself on. Interest is the fee that is paid for being allowed to borrow the money. In some cases, if you happen to be the one putting the money in some type of savings account, you may be the one getting paid that interest. Other times, if you're borrowing the money, then you may be having to pay the interest. But it's the money that's allowed for borrowing the money in some way. Simple interest is the annual percentage of the total amount borrowed or deposited. So annual is important here because that is representing an annual rate. The amount of a loan or deposit is our principal, and that's denoted by the capital P. The annual percentage paid for the use of the money is our interest rate, and that's the lowercase r. Time is always denoted with a lowercase t, and that's the number of years the interest is compounded. So we need to always keep that in years when we're talking about these interest problems. And then the capital I is our total interest earned over a period of time. Okay, we're going to be working with the simple interest formula. The simple interest formula is I equals PRT. The main thing to remember here is that rate needs to be as a decimal. So if you have a percentage rate of 4.5%, before you convert that and use it in your formula, you've got to move your decimal. You've got to move it 2 places to the left. So it's going to be 0.045 for your R. So always use the converted to decimal form, not the percentage form. Okay, this is an interest problem, and I have this little table set up here to keep us organized with the information. So on this one, it says Mary inherits $100,000 and invested in 2 certificates of deposit. These are also referred to as CDs, and a CD is just a type of savings account that banks offer sometimes, and they'll pay certain percentages for those. So one of the certificates paid 6%, and the other one paid 4.5%. And that was simple interest compounded annually. We know that her total interest earned was $5,025 per year. The question is how much money is invested at each rate. So if I look at this, I know she inherited $100,000. So that's the combined amount that's invested between the 2 CDs. So I'm actually going to put this total here. So we've got $100,000 for the total. On that, we know that one certificate paid 6%. So if I convert that to a decimal, it's 0.06. And if I convert the other one to a decimal, it's 0.045. We also know that this is an annual percentage. So each one of these is going to be for 1 year. And we also know that her total interest earned is $5,025. So if I look at this, I know she invested a combined total of she inherited $100,000 that was in those CDs and used it to invest in the CDs. So we want to know how much was in each. So we're going to let X be one of the CDs. And then when I look at this, 100,000 minus X is going to represent the amount she puts in the other CD. So if that's a little bit abstract, just think of it in terms of if you have if you invest like $10,000 in the first CD, then that leaves $90,000 in the second CD. $60,000 in the first CD leaves $40,000 in the second CD. So it really just depends on what the first one is, and then you'll do the total amount minus the first to get this. Except we don't know what the first is, so we've got to use a variable here and then do 100,000 minus that variable in order to get the principal for the second CD. So our interest, we know that interest is principal times rate times time. So we've got principal, rate, and time. So I'm just going to multiply across. I have 0.06x. And here I'm going to have 0.045 times 100,000 minus x. Okay, so this is the part that I'm going to focus on, because what we've got to do is we need to know the interest from the first one plus the interest from the second one equals the total interest. So I'm going to come down and write that as an equation. So the interest from the first is represented by this, plus the interest from the second and that equals the total interest that she earned. Okay, and now it's just a regular equation that we need to solve. We'll distribute through here, and when we do, we'll get 4,500 minus 0.045x equals 5,025. If we subtract here, we'll have 0.015x, and then subtract the 4,500 from both sides, and I'm going to have 5,025. I'll divide by 0.015, and I'm going to get x equals x equals 35,000. Okay, that's our X. So that's the amount that's in the first CD. And so that's going to be 35,000 is going to be invested at the 6% rate. And then we're going to do 100,000 minus that 35,000 is going to give me 65,000. And that's the part that's going to be invested at the 4.5% rate. Okay, and that's what our problem asked for, how much money was invested at each rate. Okay, these slides here are the slides. I've included them. They came from the textbook and they kind of go through the same ideas. So if you feel like you want to go back and read through this, then you're welcome to, but it's the same things that we talked about. Okay, so I've got a couple that I would encourage you to try and practice for yourself. But if you don't feel comfortable with that, then just listen as we go through this. The first one, we've got a rental company that charges $55 a day and 20 cents a mile for renting a truck. Michael rents a truck for 4 days and his bill came to $303. How many miles did he drive? So this one's very much like the rental car that we did. We had the fixed cost. Okay, we had the fixed cost and the variable cost, and that's going to equal the total cost. Okay, so the company charges $55 a day and 20 cents a mile. So the fixed cost is going to be his $55, and he rents that for 4 days. So he's going to pay that whether he drives the truck or not. It's $55 times 4 for the total fixed cost. The variable part of it is the 20 cents per mile. So for every mile that he drives, he's going to have to pay that 20 cents. So, and how many miles he drives is going to be represented by X. And we know that his total is 303. So when I look at multiplying this out, I get 220 plus 0.20x equals 303. And then if I want to subtract the 220 from each side, I'll have 83. I want to divide away the 0.20, and we're going to get 415, and that's going to be in miles. Okay, this practice problem, we've got a cell phone company that charges a monthly fee of $40 for the first 1,400 text messages and 10 cents for each additional text message. So this is going to be my fixed cost, and over here is going to be my variable cost. Okay, so her bill for the text messages for the month of June was $46.50, and we want to know how many text messages, so that's going to be my X. I do encourage you to write an equation to solve these. I know you could put some numbers in your calculator and try to figure it out that way, but you're really kind of missing the point of this section, and the point of it is to be able to write these equations using, be able to model these scenarios using equations. So if I go and set this up, the fixed plus the variable equals the total. So we said my fixed was going to be the $40. The variable is 10 cents, but we only pay that once we have exceeded the 1,400 text messages. So if X is the number of text messages that's going to be sent, I'm going to have to subtract those 1,400 that are, the first 1,400 are basically free or included in this $40 fixed fee. Once I pass the 1,400, then I have to start paying. So if I had 1,410 text messages, I'd only have to actually pay for 10 of those additionally. So that's why I want to do X minus the 1,400. And then altogether, that's going to equal 4650. So here's my equation, and then I'm ready to solve this. Okay, so we'll have 0.10x minus 100 equals the 4650. Go ahead and move that to the other side. Divide by 0.10. And we're going to get x equals 1465. So she had used 1,465 text during that month. So she had to pay the $40 fixed fee, and then she had to pay for 65 additional text at 10 cents per text to give her the total bill of $46.50. Okay, here's another investment problem dealing with interest. Phyllis invests $11,000, so that's going to be her total that she's investing. A portion earns a simple interest rate of 4.2% per year. The rest earning a rate of 4% per year. After 1 year, the total interest earned on these investments was $455. How much money did she invest at each rate? Okay, so this is one where we're going to do our principal, our rate, and our time, and then we're going to have our total interest over here. So on the first one, we know that she invested a total of $11,000. We don't really know how much she put in each one, so we'll let this be X, and we'll let this one be 11,000 minus X, and together they total 11,000. The rate, one rate was 4.2%. One rate was 4%. The time, these were per year, so our time's just going to be 1. And our total interest that we know that we earn is, that she earns, is $455. So we've kind of filled in the information that we know. We know the interest is principal times rate times time. So I'm going to multiply across. I'll have 0.042x, and then multiply across here, and I'll have 0.04 times 11,000 minus x. So I'm going to add the interest rate from the first CD, or the first investment, plus the interest from the second investment, and that's going to equal the total interest. And that's where I get my equation. Okay, so I'm ready to solve this. So I will go ahead and distribute through here. When I distribute here, that's going to give me 440 minus 0.04x equals 455. So we'll combine our x's together. So if I subtract this minus this, I get 0.002x. And then if I subtract 440 from either side, I'm going to get 15. I'll divide by 0.002. And so I'm going to get x equals 7,500. The x represented that was at 4.2%. So I'm going to have 7,500 at 4.2%. And then I'm going to have to do 11,000 minus 7,500, which is going to give me 3,500. And that's going to be at the 4%. Okay, some of our models that we're going to be referring to are geometric in nature. They may be area formulas, they may be volume formulas, they may even be the Pythagorean theorem that involve geometry. This particular example, we have a square garden that has a walkway that's 3 feet wide around its outer edge, and we see the diagram here. If the area of the entire garden, including the walkway, is 18,000 square feet. So we've got 18,000 square feet is the total area. What are the dimensions of the planted area? So we're looking for the dimensions of the planted area. So we're going to let X be one of the sides of the planted area. So this is going to be X. That means this side here is also X. We're putting a 3-foot wide walk around this. So in doing that, we're going to have 3. So this is going to be 3. This will be 3. And going the other direction, this is also X. This would be 3, and this would be 3 because our walkway is 3 feet wide in each direction. So my total for this side is going to be X for the planted area plus 6 for these 2 walk areas here. Same thing on, excuse me, on this side. We're going to have X plus 6. So we've got the X for the planted area plus 3, and 3 gives me 6. So using the model, area equals length times width. My area was 18,000 square feet. My length was X plus 6, and my width was also X plus 6. So in solving this, I could go ahead and multiply this out and bring the 18,000 over and use the quadratic formula. But what I'm going to actually do here is a little bit simpler. If I write that as X plus 6 to the second, I can go in and take the square root of each side. So I'm going to have my square and my square root will cancel. We'll have X plus 6. Here we're going to have the square root of 18,000. So X is going to be the square root of 18,000 minus 6. And the thing with word problems is we generally want to go ahead and write this as a number. And so this is going to be 134.16 minus 6. So X is going to be approximately 128 feet. So the dimensions of our garden for the planted part is going to be the X, and that's going to be 128. So it'll be 128 this way, and it'll be 128 across. So we don't really like to say like, oh, the length of a garden is the square root of 18,000 minus 6. Because, I mean, people have a hard time wrapping their mind around what that means. So generally in word problems, we are going to go ahead and give an approximation for that using the calculator. Okay, so here are some slides that kind of go through, again, from the book that talk about how to do this. I have included them just in case they help you in any way to stop and pause and look at them. One thing that I did not mention that I'm going to go back to very quickly here is when I took the square root of that, technically it would have been plus or minus, but because a side has to only be positive, I didn't have to worry about the minus case with that. Okay, so I'm going to get back to where I was. Okay, here's another example, and this one also uses length times width. We have a rectangular building lot that's 8 feet longer than it is wide, and it has an area of 2,900 square feet. We need to find the dimensions of the lot. So we're going to start with a rectangle here to represent the lot. The lot, we know the width of it, we're going to let be X, and the length is 8 feet longer than it is wide, so that's going to be X plus 8. We also know that the area inside here is 2,900 square feet. So using the area equals length times width again, our area is 2,900 square feet. Our length is X plus 8, and our width is X. Okay, we're ready to solve this. So we'll have X squared plus 8X, and that's going to be equal to 2,900. Hopefully you recognize that this is a quadratic because it's got the square term. That means that we need to get everything equal to 0 before we can solve it. This actually does factor if you want to factor it. If you don't want to factor, then jump right in and do your quadratic formula. So we'll have negative b plus or minus the square root of b squared minus 4 times a times c. Okay, and that's all over 2 times a. So I'll have -8 plus or minus. If I simplify all of this, I actually get 108, and then that's over 2. So that's after you've taken the square root, it's going to be 108. So I'll have -8 plus 108 over 2 and -8 minus 108 over 2. So this is going to be 50 over 2, sorry, 100, getting ahead of myself, 100 over 2, that's going to be 50. And this one's actually going to give me a negative, so I'm going to eliminate that right off the bat because I can't have a negative for the side of a lot. Okay, so 50 is going to be my x, 50 feet, and this is going to be 50 plus 8, which would be 58 feet. Okay, the next type of problems that I would like to look at are those involving mixtures. Okay, with the mixtures, problems involving mixtures and concentration make use of the fact that if an amount X of a substance is dissolved in a solution with volume V, then the concentration C of the substance is given by X over V. So the amount of the substance is dissolved in a particular volume, and that gives us the concentration. We're actually going to work with this form a little bit more than this form today, because we're going to say the concentration and the volume of the first substance plus the concentration and volume of the second substance is going to equal the concentration and volume of the final or total substance. Keep in mind your concentration will be given to you as a percentage, and you need to convert that to a decimal to use that in your equations. Okay, so here we have a manufacturer of soft drinks advertises their orange soda as naturally flavored, although it contains only 5% orange juice. A new federal regulation stipulates that to be called natural, a drink must contain at least 10% fruit juice. How much pure orange juice must this manufacturer add to 90 gallons of orange soda to conform to the new regulation? Okay, so our first mixture or substance is going to be the orange soda. So we're starting with the orange soda. And we know that the orange soda has a 5% concentration. So that's going to be 0.05 for its concentration. And we also know that from the end here, it says how much orange juice must the manufacturer add to the 900 gallons of orange soda. So that's the volume that we're going to start with, 900 gallons of the orange soda. From that, to the orange soda, we're going to add our pure orange juice. Okay, so adding the pure orange juice, the concentration of anything that's pure is 100%. So 100% converted to a decimal is going to be 1. And that's the part that we don't know because it says how much pure orange juice. So that's our unknown, which is the X. And then the final solution, in order for it to be labeled as natural, it has to have at least 10% fruit juice. So we need to end up with 10% fruit juice. And the volume, if we have 900 and we add X to it, the volume that we're going to end up with is 900 plus X. Okay, so we're going to go through and we're going to multiply the concentration and volume together on these, and that's going to help us to write our equation. So we multiply these first two together, we're going to get 45. Here we're going to have 1x. And then on this one, we're going to have 0.10 times 900 plus x. So we're going to make our equation, and it is super important that you are writing the equations on these and not just trying to figure out it by typing numbers in your calculator. So we're going to have the concentration times the volume of the first substance. And then we're going to have the concentration and the volume of the second substance, and that's going to equal the concentration and volume of the final substance. Okay, so for the first substance, when we multiplied concentration and volume together, we got 45. The next one, when we multiply those together, we got x. And then finally, we're going to have 0.10 times 900 plus x. So this is the equation that we need to solve. If I distribute through here, I'm going to have 90 plus 0.10x. That's going to equal 45 plus x. This is a linear equation, so we just want to get the x's on one side and the numbers on the other side. So if I subtract 0.10 from both sides, I'm going to have 0.9x. And then if I subtract 45, I'm going to have 45. So I'll have 0.9x equals 45. Divide by 0.9, and I'm going to get x equals 50. And this is going to be in terms of gallons. So I need to add 50 gallons of pure substance, 50 gallons of pure orange juice to the orange soda in order to end up with a 10% fruit juice concentration. I think this is a very good visual here of what we're doing. We've got the 900 gallons of the 5% juice. We're going to add 100% juice to that. We don't know how much we're going to add, but we're going to add some. And we want to end up with the 10% juice. And you can see that you're going to combine these two volumes together to get this total volume here. Okay, here's a practice problem that I would like for us to take a look at. If you feel comfortable with what we're doing, pause it and give it a try. I would certainly recommend that. If you don't feel quite comfortable, then listen to what we're going to be doing here. This one says what amount of a pure acid must be added to 500 milliliters of a 60% acid to produce a 75% acid. So we're going to start with our concentration and our volume, and then we're going to have our total here. So we've got our substance 1, and we've got our substance 2, and then we've got the total that we want to end up with. Okay, so we're going to start with a 50 milliliter solution of 60% acid. So we've got the 60% acid for the concentration. The volume of that is going to be 500 milliliters. And so if we multiply that together, we're going to get 300 for the total there. The substance that we're going to be adding to it is pure acid. So the pure tells us it's going to be 1. We don't know how much of the pure acid we're going to add, so that's going to be x. So we're going to end up with 1x. We want to end up with a 75% acid solution. We had 500 to begin with, and we added x to that, so our volume would be 500 plus x. We multiply across here, we're going to have 0.75 times 500 plus x. So now we're ready to write our equation. So our concentration, so our total over here is the concentration times the volume. So our concentration times the volume for the first substance is 300. For the second substance is 1x. And then we have for the total substance is 0.75 times 500 plus x. If we multiply these two together, we're going to get 375. And this is a linear equation. So we just want to combine the x's on one side and the constants on the other side. If I subtract 0.75, I'm going to get 0.25x. If I subtract 300, then I'm going to get 75. Divide by 0.25. And x is going to be 300, and that's going to be milliliters. Okay, the last model that we're going to be looking at is problems that involve finding the time needed to do a job. These are the type problems where one person completes the job in a certain amount of time and then another person completes it in a different amount of time. We want to know if they work together, how quickly they can do it. So just because the two are working together doesn't mean they cut the amount of time in half because people work at different rates. And so that's what's going to be taken into account on this model. If we look at this, our model for this is 1 divided by the time it takes the first person or machine or whatever we're talking about, plus 1 over the time it takes the second person or machine, and that's going to be equal to 1 over the total for that person or machine, the total time that is. Okay, so here's an example. Because of an anticipated heavy rainstorm, the water level in a reservoir must be lowered by 1 foot. Opening spillway A lowers the level by this amount in 4 hours, whereas opening the smaller spillway B does the job in 6 hours. So B is going to take a little bit longer to accomplish the same thing. How long will it take to lower the water level by 1 foot if both spillways are open? I will say the 1 foot on these is irrelevant because basically both of these times are the times given to accomplish that job. So the job is lowering it by 1 foot, and so we don't use the 1 in our calculations at all. So we're going to have 1 over the time it takes for spillway A plus 1 over the time it takes for spillway B. That's going to give us 1 over the time it takes for the total of the two. So we'll have a fourth, and then we're going to have a 6 because it takes 4 hours for A, 6 hours for B, and then that's going to equal the time for the two together. So you can either add these together on your calculator, or you can get a common denominator and add them together. Your common denominator would be 12, so this one would need to be multiplied by 3. This one's going to need to be multiplied by 2. So we're going to end up with 3 plus 2 over 12, or 5/12. Okay, you can cross multiply, divide by 5, and you'll see that the time it takes for the 2 is 12/5, which is 2.4 hours. So one took 4 hours, one took 6 hours, and then when they worked together, they took 2.4 hours to complete the job. Another way, instead of cross multiplying, is just to realize that you need to get the 8, you need to flip each one of these. So if I'm flipping 5 twelfths, it's going to be 12/5. 12/5 is 2.4 hours. Okay, I have a few examples here for you to practice on. I would certainly recommend that you're stopping and trying these, but if not and you're not comfortable, then keep watching and we'll go through some more of these. So this is another mixture problem here. It says what amount of a 55% acid solution must be mixed with a 30% solution to produce 400 milliliters of a 45% solution. So we've got our concentration and our volume, and then the product of the two, and this would be for substance number 1 and substance number 2. So we're going to start with our 55% acid solution. So we'll have 55%, and we need to know what amount of that. So that's going to be our X, and we're going to mix that with a 30% solution, and we need to produce 400 milliliters. So our total is going to be the 400. And we want the total to be 45% concentration. So we need to go back and figure out what the volume here is going to be. If we need to end up with a total of 400 and we're going to use X of it to be the 55% solution, then we're going to have to subtract 400 minus X to give us the 30% solution. So we're going to multiply these through, and we'll have 0.55X. Here we'll have 0.30 times 400 minus X. And then here we're going to have 0.5 times 400. And that's going to give us our equation. We're going to have the first two substances combined together, gives us the last substance. So 0.55X plus 0.30 times 400 minus X, and that's going to equal 0.45 times 400. Okay, we're going to distribute here, and if we distribute, we are going to get 120 minus 0.30x, and then that's going to give us 180. Subtract our x's and we'll have 0.25x. Subtract the 120 and we'll have 60. So when you divide by 0.25, you're going to get 240, and that's going to be milliliters. And so that is representing our 55% solution, which is what the problem asked us to give. Okay, moving on. A rectangular bedroom is 2 feet longer than it is wide. Its area is 143 square feet. Excuse the typos. What is the width of the room? So we've got a rectangular bedroom here. It's 2 feet longer than it is wide, so we'll let x be the width, and then x plus 2 is going to be the length of it. The total area is 143 square feet. So we want to know what is the width of the room. So the width we said was our x. Okay, so we'll multiply these together because we'll use the model length times width. So our area is 143. Our length is x plus 2, and our width is x. So we'll have x squared plus 2x, and that equals 143. This is a quadratic, so with quadratics we need to set it equal to 0. Okay, this will factor into x plus 13 and x minus 11. So if you don't recognize that this factors, then go ahead and use the quadratic formula and you should be able to solve that. So take each of these parentheses and set them equal to 0. So we'll get x equals negative 13 and x equals 11. We're going to have to eliminate this one because we can't have the negative side of a bedroom. So x is going to be 11 feet for our answer on this one. Here we have a ladder that leans against a building. The base of the ladder is 7.5 feet from the building. How high up the building does the ladder reach? So we have our building here, and we're going to have our ladder that leans against the building. So we have a 19.5 foot ladder. So that ladder is going to be represented here. It leans against the building. The base of the ladder is supposed to be 7.5 feet from the building. So this would be 7.5. How high up the building? So this is going to represent how high up the building does the ladder reach. Hopefully you remember that when you work with right triangles, you can use the Pythagorean theorem. And the Pythagorean theorem says a squared plus b squared equals c squared. You can only use this for right triangles, and c has to be the hypotenuse, which is the side opposite the right angle. So here we're going to have 7.5 squared plus b squared equals 19.5 squared. So we can simplify these. So we'll have 56.25 plus b squared. That's going to be equal to 19.5 squared, which is 380.25. So b squared, we're going to subtract the 56.25, and we'll have 324. Take the square root of both sides, and we're going to get plus or minus 18, but because we're talking about real sides here, b is going to be equal to 18, and that would be feet. So the Pythagorean theorem is another model that you may use when you are setting up these problems, especially if they're geometric. Okay, we have another example here. We've got a square plot of land that has a building that's 40 feet long and 20 feet wide at one corner. The rest of the land outside the building forms a parking lot. I apologize for all the typos today. I must have been asleep when I was typing these. Okay. If the parking lot has an area that's 11,300 square feet, what are the dimensions of the entire plot of land? So I would certainly recommend sketching this out. So we're going to start with the square plot of land here. Okay. And it has a building that's at one corner. So this is going to be the building over here. Again, apologizing for my not so straight lines. The building is going to be 40 feet long and 20 feet wide. The rest of the land outside the building forms a parking lot. So this part here is our parking lot. If the parking lot has an area of 11,300 square feet, what are the dimensions of the entire plot of land? So we know it's square, so we're going to let this side be x, and this side will also be x. So we need to set up a formula for this. So the area of a square we know is side times side, or length times width. So the area of the total, we're going to do the area of the total minus the area of the building, and that's going to equal the area of the parking lot. Okay, so our total area of this whole big plot of land is x times x, or x squared. The area of our building, we know it's 40 by 20, so the area of the building is going to be 40 times 20, which is going to be 800. And then the area of the parking lot is 11,300. So we have a fairly simple equation to solve from here. We'll just take 800 from the 1130. I mean, not 1130, 11,300. Okay. Okay, so we actually need to add the 800 to both sides here. And when we do that, we get 12,100. We'll take the square root of both sides, remembering the positive is the only one that we need. And so our answer on this is going to be 110 feet. And it is a square plot of land, so it'd be 110 by 110. Okay, Candy and Tim share a paper route. It takes Candy 55 minutes to deliver all the papers, and it takes Tim 95 minutes. How long does it take the two when they work together? Okay, on this one, this is where we're combining the time it takes the two to work to do a job and see how long it takes them to work together. So we're using the model 1 over h sub 1 plus 1 over h sub 2 equals 1 over h sub total. Okay, we know that the first one, it takes 55 minutes, and the second one, it takes 95 minutes, and we need to figure out their total. So we need to combine these two fractions together, and you can either get a common denominator or do it on the calculator. If you do it on the calculator and reduce it, you're going to have 6 over 209. Okay, so that leaves us with the total time is 209 over 6, which is 34.8333, and the threes are repeating here. So basically what that's saying is it's going to take 34 minutes. And then to find out how many seconds, we're going to take this part, we're going to take the 0.83 repeating, multiply that by 60, and we're going to see that that is equal to 50 seconds. So we got 34 complete minutes and then 0.83 repeating seconds. So 0.83 times 60 seconds gives us a total of 50 seconds. So 34 minutes and 50 seconds. Okay, Stan and Hilda can mow the lawn in 20 minutes if they work together. If Hilda works twice as fast as Stan, how long does it take Stan to mow the lawn alone? So we're going to let Hilda represent the time it takes Hilda is going to be X. So if she's working twice as fast as Stan, this is where it's a little bit confusing. If Hilda works twice as fast as Stan, it's going to take Stan twice as long to complete the same job. And we're focused on how much time it takes to complete the job. So Stan's time is actually going to be 2 times Hilda's to do the same job because Hilda works twice as fast as Stan does. Okay, the total time we already know that the two work together is 20 minutes. Okay, so when we set this one up, we're going to have 1 over Hilda's time plus 1 over Stan's time, and that's going to equal 1 over the total time. We need to get a common denominator here, so I'm going to have to multiply this one by 2. So I'm going to have 2 plus 1 over 2x, and that's going to equal 1 over 20. So 3 over 2x is equal to 1 over 20. Here we do need to cross multiply to solve this. So I'm going to have 2x is going to be equal, we'll multiply this way and get 2x, multiply this way and get 60. So x is going to be 30. So it's going to take 30 minutes for Hilda to complete the task, and it's going to take Stan 2 times 30 or 60 minutes to complete the task. Okay, that takes us to the end of all these examples involving modeling. So you can see there's a few, 4 or 5 different models that you're going to be going back to over and over again. So there's lots of examples here. If you need to go back and watch that, feel free to do that. And also take advantage of any of the resources within the class.